a student constructed a series circuit consisting of a 12-volt battery, a 10-ohm lamp, and a resistor. The circuit does not contain a voltmeter or an ammeter. When the circuit is operating, the total current through the circuit is 0.5 ampere. So 66. In the space in your answer booklet, draw a diagram of the series circuit constructed to operate the lamp using symbols from the reference tables for the physical settings/physics. So, remember, the series circuit is one in which the current only has one path to go through. So there's going to be no branches in our circuit. It's just going to be the battery, the lamp, and the resistor. There's going to be, again, no paths. They'll come one right after the other. So let's start with our battery symbol here. We have a wire. Let's draw a resistor. And then we have a lamp. And that's it. So that's our series circuit, right? We've got our battery, resistor, and a lamp. We're good. There's no branches or anything. That's it for 66. Now, the equivalent resistance of a circuit. Now we're starting to analyze the circuit. We're going to have to set up our table. Remember, we have that verb chart that we can use to help organize all of our information. What are our devices here? Well, we've got a lamp. We've got a resistor. And then we've got the total, right? The total current, the total voltage, so let's fill in what we know here. What's some of the information they gave us here? It's a 12-volt battery. Remember, when you think of the battery, you should generally think of the total. So that's the total voltage being supplied to the circuit. It's a 10-ohm lamp. Ohm, so that sounds like the unit for resistance. So the lamp's resistance is 10 ohms. Then we've got a resistor. We don't know much about the resistor. When the circuit is operating, the total current is 0.5 amperes. So the total I current is 0.5 amps. And it looks like we pulled out most of the information that they gave us here. What are we looking for? The equivalent resistance of the circuit. Remember, equivalent resistance just means the total resistance. So if we look at our table, which of these boxes are we trying to find? That's this one right here, the total resistance. Well, what can we do to find that? Well, we don't know the two resistances, so we can't do that, but we do know the total voltage and the total current. Well, voltage, current, resistance. What's an equation with all of those things in it? R equals V over I. We're solving for R. We can plug in, again, we need to be consistent here, the total voltage and the total current. So we plug in 12 volts over 0.5 amps, and we get 24 ohms. The total resistance. Now, we can plug that in right here. Right now that we know the value, we can throw it in our table, and maybe we can use it for the rest of the problems. 68. Determine the resistance of the resistor. Well, how do resistances add up in a series circuit? Well, they just add up one on top of the other. You'll remember from your reference tables, the equivalent resistance is equal to R1 plus R2. And if we set that up for this problem, well, the equivalent resistance we just found, right? It was 24 ohms. And that's equal to R1. That's what we'll find, right? We're going to find the resistor's resistance plus the resistance of the lamp, which is 10 ohms. Subtract the 10 from both sides. And what do you get? 14 ohms. Notice that the 10 ohms from the lamp plus the 14 ohms from the resistor add up to the total resistance, right? One of the properties of a series circuit. And lastly, for 6970, calculate the power consumed by the lamp. So we're looking for the power from the lamp, right, which is going to be this one right here. Well, we need two values. We need the voltage, the current, resistance. We need two of those three to find the power. Now, it looks like we don't have enough information here, but remember, the current in a series circuit is the same through every device. And so the total of 0.5 amps is equal to the current through the resistor, 0.5 amps, which is equal to the current through the lamp, 0.5 amps. Now we know I, the current, we know R, the resistance. We're looking for power. What's the equation with all three of those things in it? P is equal to I squared times R. Plug in here. Well, I is 0.5 amps. Don't forget to square. R is 10 ohms. Plug in and you get 2.5. What's the unit for power? Watts.